Hi everyone, welcome back to my channel. If you are new here, welcome. If you are a returning subscriber, welcome back. If you are new, don't forget to subscribe and be part of our family. And before we start with today's topic, please don't forget to like this video, share with others, do subscribe if you are new here, and follow me on Instagram for some extra motivation. You can see my Instagram handle on the screen, and do let me know if there is a topic you want me to cover, if you have any queries, and any feedback is always welcome. Without further ado, let's get started. Hey everybody, so in this video lecture we're going to talk about basic elements of programming, and the reason I'm creating this video is because these are like the fundamental concepts of programming, and you should learn about these things in the very beginning. But when I started this channel, obviously all my students were like, they already had knowledge of basic elements of programming, and then as the channel started growing, I started receiving more requests. So anyway, so the reason I'm creating this video is because I received a request from somebody who is new to programming. Actually, there are 2-3 friends, I guess. So they are completely new to programming, and they are finding it very hard to understand what actually makes a program, right? So these are the basic elements of programming that we're going to discuss today. And no matter what programming language you pick, you decide to learn, these elements are going to be the same. Obviously, the way they are represented, their presentation, their syntax can be different, but all programming languages will have these basic elements. Okay, and obviously you know what programming language is. If you don't, check the very first video on this channel. I've explained why we need programming and all of that. So let's talk about basic elements of programming. So first of all, just remember that basic elements of programming, these are the fundamental building blocks of a program. Okay, so all programming languages will have these elements, and they may differ in the presentation or how their syntax looks like, all of that, right? So the very first element is variable. Okay, we are going to start with variables first. Okay, and variable, right? So as its name suggests, variables are values that can vary, that can be changed, right? That's what variable means. It keeps on changing. Keeps on changing doesn't mean that once you store a value in variable, it will automatically change. No, it only means that you can change the value. Okay, so you should remember that. And what variables actually are? Variables are, these are the name, you can also say these are the names of memory locations where values are stored. So as you know that in computer, when you are storing a value, memory addresses are not in the form of names or English letters, or simple numbers like 1 2 3 and all of that. They are address. It's very hard to remember the address. Computer memory address is very hard to remember because they are in the form of hexadecimals, right? Since computer understands binary only, zeros and ones, so addresses are not really easy to remember, memory addresses. So if you ever try to save something in computer and you want to access it using the address, it's going to be very hard. You'll have to remember the address, you know, and then write it down and all of that. So to ease that, to make it easy for the user, variables are used. Okay, instead of remembering that address, we are using variables. Okay, so name of memory location where the value is going to be stored is what a variable is. It makes it easy to access the value with the name. So for example, if I say a equals to 10, so value of 10 is stored somewhere in memory, but I don't have to use that memory address. Instead, if I want to access the value, I can use a, and whenever I use a, it means I'm going to pick that value from the memory address. So a here helps. A here is name of the memory location. Okay, so this is what this is the use of variable, and like I said, these values can vary. So if I have a equals to 10, if in the next line I'm going to write a equals to 9, the value is going to change. Let me show you here. So a equals to 10, right? Now 10 is stored somewhere in the memory, and if I want to access if I want to access the value, this value 10, I don't have to use the memory address. I can use variable name a, and whenever I use variable name a, it's going to fetch the value from the memory. Okay, but since it's a variable, I can also change the value. So for the next line, I'm not using the term statement because we'll explain that later. So if I say a equals to 9, and now if I try to fetch the value, it's going to be 9. So this is a variable. Value can change. Okay, and it's also name of memory location where the value is stored. So I hope that's clear. Then we have constants. Okay, now I actually tried to create a combination to make it easy for you to remember. All right, so let's talk about constants now. So variables are values that can vary easily. Constants are values that remain constant, so they cannot be changed. Okay, constant is also name of a memory location. You can say it's a variable, but the value will not change. So in other words, constants are also name of some memory locations. So a certain value has been stored there, you can say, but these values cannot be changed. Okay, and constants can be user defined or it can be built-in constants, right? And I'll actually create a different video on constants where I'll explain how you can create your own constants. Okay, built-in values meaning that there are certain constants and their values are fixed. Okay, for example, in maths module, there are certain values that are already these values never change, and you can use them for mathematical operations and everything, but I'll create another video on constants specifically after this video. Okay, so constants are values that never change, right? Just remember that. So we have variables, we have constants. Variables obviously both refer to memory locations where certain values are stored, but for variables, values can vary, values can change. For constants, values remain the same. They remain constant. Okay, so I hope this is clear. Variables and constants. Now let's talk about identifiers and keywords. So first we have identifiers. As its name suggests, it is used to identify something. Okay, if you look at a program, any program for that matter, let's say I have another value b equals to 8, sorry, b equals to 8, and we have a plus b, then I'm saying print b, like that, So all these programming elements are to be identified, right? 8, this memory location is identified by B, right? This is A, right? And if you remember, if you want to create your own function, so we use def, and then you can write, let's say I want to create a function to add two numbers, right? So I can give any name. I can write add, I can even give parallel, because this is not set in stone, or this is not fixed, right? User provides this name, okay? And these names are used to identify that variable. These names are used to identify. So in this case, this is going to be name of the function or the method if I provide it here, right? So these are called identifiers. They are used to identify a variable, a class, or a function, or an object, or a module. Basically, name given to a programming element is called an identifier. So because these are all programming elements, variable is a programming element, constant is a programming element. If I create a function here, let's say def add is going to be a programming element, right? But since I am providing the name, it's to identify that particular variable or that function. It's called an identifier. Okay, so name given to a programming element by the user is called an identifier. All right, then we have keywords. Okay, so what are keywords? Now keywords are, so identifiers are user given names. Keywords are reserved words or predefined words. Okay, so user does not provide keywords. They are already there. Okay, they already have a specific meaning, right? So they can't also be used as identifiers. For example, print, right? If I use print function name, I know what it is going to do. It's going to print some value, right? So print already has a function. It already, there is specific meaning associated with print. It will do something, right? So this is a keyword. Similarly, def, right? I am providing add, right, name of the function, but def, if I use def before this identifier, it means I'm trying to create a function. So def already has a predefined meaning, that if you use def before a name, it's going to create a function, right? So def is also a keyword. Okay, keywords have predefined meanings. They are reserved words, right? If I, for example, say print equal to 90, so I'm trying to use print as integer variable or variable, right? I'm trying to assign this value 90 to print. If I try to print the value of print, it's going to say, it's going to give you an error. Int object is not callable, right? Okay, yeah, just remember that keywords can't be used as identifiers. Okay, so that's that's the main difference between identifiers and keywords. Keywords are predefined, and identifiers, these are given by the user. Okay, so just remember that. Then we have another programming element, data types. So what are data types? As its name suggests, it is used to define type of data used in computer, because computer is a machine. If you say 1 plus 2, computer will not know what is supposed to do with these, these things. provided. So you have to make computer understand what these quantities are, or these values are. So data types are used to tell the computer the type of the data given to it. Okay, and data types are also keywords. They can be user defined or built in. We'll talk about that also. I'll create another video specifically on data types to help you understand that. So just remember that, as its name suggests, data type of data to be used in the computer. Just remember that. So data types are used to tell about type of data used in the program or the computer, right? And it helps computer understand the type of data computer is dealing with. Okay, let me give you an example. So for example, let's say in many other programming languages like C, C++, usually we first declare the variable. So if I say a equals to 9, I first need to make computer understand this is a is of type integer. Okay, so data type for a is int, and then computer will know what kind of operations can be performed on this data type. Because if I try to multiply two strings, it's not going to happen, right? So once you provide the data type of that specific variable, computer now knows what operations are possible on this value and what operations are not possible on this value. And consequently, computer can actually generate it can generate errors or the result, right? And since Python is dynamic programming language, what that means is you don't have to declare variable. You just, when you provide the value, it automatically knows the type. So if I say equals to 9 and type function is used, now type here is a keyword. Okay, type function is used, this function is used to know the type of to know the data type of specific variable. Okay, a is a variable here, right? Identifier variable. So a equals to 9, type a int. If I say a equals to 9, or let me take another variable. I can obviously change the value because it's a variable, but I'm gonna take another variable. So type b, it's a string, right? Because I'm using quotes here. So type function is used to identify the type of data, right? So that's what's the use of data types. And if you have any doubt anywhere in the video, please do let me know. I'll try to explain that specific portion again. So these are data types. I hope it's clear. Then we have statements. Statements are commands in the program, right? So whatever you write, if I say print a, this is a statement. Okay, whatever you are writing in the program, it is a statement. These are called statements, or instructions. Basically, you are using in the program is made of instructions. Okay, a program, what is a program? It is made of instructions, right? Or commands or statements. And these commands are used to tell computer what to do, right? So that's what statements are. Now sometimes they are also statements are taken for expressions and expressions are taken for statements sometimes. So they are not the same, they are different. Statement, as I said, statements are commands in the program, commands or instructions in the program. Expressions, on the other hand, is a combination of three things: operator, operand, and value. Okay, so main difference is in terms of value. Statement doesn't have it. Okay. Expression will have it, right? So what is an expression? It is made of operator, operand, and value. What is operator? Operator is like addition or multiplication, subtraction, division, any action or any operation that you want to perform, that is represented by operator. Okay, operator represents a specific action that is to be performed. And what is an operand? Operand is the value on which that action will be taken, right? So operator represents an action that is to be taken on the operand. So if I say A plus B, right, plus here is the operator, A and B are the operands. I've already created a video. I created on expressions, on different types of operators, right? So you can check that as well. So this is an expression, A plus B, right? And obviously if I say C equals to A plus B, this is also an expression. It's going to generate a value, and statements don't always generate a value. Okay, so that's the main difference between statement and expression. I hope that's clear. Next we have control structures. Now control structure meaning flow of control in a program. Okay, when you are executing the statements in a program, what is the flow of control? Now, usually, what is the flow of control? It is sequential. Okay, but you can change it. Okay, so I'll give you an example here. So just remember that control structures represent flow of control in a program, how the control is going to flow in a program. So for example, if I write these statements, hi, welcome to this program. Okay, wait a minute. I'm actually going to create a new file, right? Then I'm going to say A equals to 9, B equals to 8, C equals to A plus B, and then I'm going to say print value of C. That would be that actually. So I'm just going to create a very simple program. Okay, so natural or common flow of control of a program is sequential. Okay, so program control in a program works in a sequential manner. So it will first come to this statement. Okay, it will perform the action. So this statement is asking to print this string, so it's going to print it, right? In the next statement we are assigning 9 to A, so it's gonna do that. In the next statement we are asking to assign 8 to B, it's going to do that. Then we have an expression C equals to A plus B. So it's going to add these two values and then assign the add these two operands and then assign the value to C. And in this statement we are printing the value of C, so it's going to do that, right? So it's going in a sequence. Let me run it, right? So that's what we have here. First it's going to print the string and then it's assigning the values behind the screen and it's going to print the value. Okay, all right. So this is a normal flow of control. Okay, now we can change that. And how do we do that? To change this sequential flow of control, we have various other control structures. We can use a loop if we want that something should, if we want that certain statements should repeat over and over again. So for example, in this case, if I want that instead of printing the value of C, this statement or these statements or something should repeat over and over, I can just use a for loop here and keep these statements inside the loop. Okay, similarly we can use if else statement, right? Anything that will hinder the normal flow, anything that will change the normal flow of the program. So for example, let me give you an example. So I'm gonna say if a less than 10, print a is not greater than 10. Okay, else print all good. So now if I run this, as you can see, when it comes here, I'm gonna use this statement here. So if A is greater than 10, then it's going to print the value of C. Otherwise, it's not going to do that. Okay, so in a way, I'm actually changing the flow of control. So, right, so this is the output. It's going to, control comes here, it prints the first, this string, it prints this string, then equals to 9B8, C, A plus B, then I'm changing the flow of control. So if value of A is greater than 10, then it's going to print A is not greater, A is greater than 10, and it's going to print the value of C. Otherwise, it's just going to print all good and it's not going to print the value of C. So in a way, I changed the flow of control, right? If I remove these statements, it's again going to have a sequence, a sequential flow. So as you can see, it's going to print all the statements. So that's why we use control structures, right? And these were some of the basic fundamental elements of programming. I hope it's clear. If it is still not clear, please let me know. If you have any doubt anywhere, let me know that as well. I hope it helped. I'll see you in the next video lecture. I'm gonna create one on constants and then another one on data types. So if you have any queries, do send them my way, and I'll see you in the next video lecture. Till then, take care.